Okay, so now we're going to be doing what's called a system of those inequalities. So we just saw how to graph one inequality. For example, here's one inequality. If I asked you to graph it, you would get it in y equals mx plus b form, which is this. And then you would graph it, and then you would read and shade correctly. You'd say the y values below the line or equal to the line are solutions. So I'm shading below. We have a solid line. And we know how to graph one inequality here. We'd get it in mx plus b form, so I subtracted 4x, then I divided by -2, remembering to switch my inequality, giving me this. So I graphed the line, and I read it. Y values above the line, right? So I shaded above. Now what we're doing in 4.6 is we're literally doing that same thing, but we're merging the answers together. It's an intersection. So we're going over here, and now we're going to have 2 or more of these, and we have to have, the solution will only be the intersection of this, so where they both happen at the same time. It's never or, it's always and. So if you look right here, look, I've graphed the blue line, the same as I did here. I've graphed the red line. Now this is a little trick I use to help me shade correctly. I write next to the blue we were shading below, and the red we were shading above. So I write that down. So it has to be that at the same time. Above red, you see how I'm above red? Right here? But at the same time it has to be below blue. So that only happens right here. Do you guys see? So the solutions would be anything that falls in that set. Solid lines are solutions, dotted lines aren't. So, for example, over 0 up 3 would be a solution. Over 2 up 1 would be a solution because that's a solid line. There's no dotted lines here. Are we good? And so on. Okay, awesome. Let's just practice that. So, graph the system. So the first thing you would do is rewrite it in mx plus b form. So looking here, I'm going to add 2x, add 2x. So I have y values larger than 2x plus 5. With this one, I'm going to subtract 3x, subtract 3x. Then when I divide by 2, so we would have our y values greater than or equal to, split it up and put it in mx plus b form, so -3 halves x. And then right here is -2. So let's graph the first one, just focusing on graphing y-intercept of +5 and our slopes of 2 over 1. Then is it including the line? Nope. So this line is going to be dotted. Then I always write, somewhere at least, right here by the line. It's y values above the line. So I'm going to write above. So I can think about that in a minute. Now ignoring that line, ignoring it, and graphing this one. So my y-intercept's at -2. My slope is down 3 to the right 2. 1, 2, 3, right 2. And then it is including the line, so this one's a solid line. And then this one is y values above, so another above. So let's think about where the final shading would be on this one. It's got to be above both. So let's think about above blue. Above blue is all right here, true? Above red is all right here. It's got to be above on both. Isn't that right here and right here? And only right here. Does everybody see? So then our solutions would be anything that falls in this region, but not on a dotted line. So there's our solution set. So -4 up 4 is a solution. However, everybody watch, -2 up 1 is not a solution. Here's why. That falls on the blue solid line, yes, but isn't the red line dotted? So it doesn't work for red. This is the intersection. So it's got to work for both. So that would be a no. Over -1 up 3 is a no. Does that make sense, everyone? And we're done. So it just takes practice, honestly. So let's do another one. So mx plus b form. So we'd have our y values, subtract 2x, subtract 2x. So y values greater than -2x plus 2. Then right here, subtract 2x. Something interesting happens on this one. y values less than negative 2x minus 2. So focusing here and graphing, y-intercept of 2 down 2 over 1. Solid, nope, dotted line. My bad. Then we're shading that one. Y values above, so above that one. Let's graph this next one. So y-intercept of negative 2, then my slope's negative 2. And that one is dotted as well. And in this one, it says y values below the line, below. So let's see about shading that. If we shade below this, and then we shade above this, will they ever intersect? In this case, no, so this one would be no solutions. We can still graph it, it's just there are no solutions for this one. So if I said graph, there it is, but that means there are no solutions. Make sense? If these signs would have been different, and we would have been shading in here, those would all be solutions. Does that make sense? Okay, cool. All right. Do you want another example of this intersection, or do you guys feel good? I can do one more. I can move on. Okay. So I just want to, this one I just want to be sure that we're good with it. So, just watch, we'll go quick. Y values equal to negative 4. So that's right here, correct? Y value of negative 4. It's a solid line. This is going to help. We're going to start having more than just 2 in a second. Then we're graphing this one. I'll keep the same color. So down at negative 3, and then our slope's up 1 over 1. So this will be pretty quick here. This one is a solid line as well, looks like. So now let's see here. We're shading above negative 4, right? Above that. And then we're shading below this line. So above and below. Where would that be? Right here, right? Above this line, but below this line. All this stuff. Okay, awesome. Okay, it says, is this point a solution to the system? You could graph it and check, or you could just plug in x, y points. But guys, you got to plug it into the top and bottom. So I'm checking to see if 2, 4 is a solution. So you would plug that in here and here. Let's see if it's a true statement. 3 times x, y. So 3 times 2 plus 4 is less than or equal to 7. 6 plus 4 is less than or equal to 7. Is 10 less than or equal to 7? No, so if it doesn't work in one or the other, you automatically know it's a no. So this one is no. That's not a point. Even if it worked right here, it doesn't work in the first one. So right here, x, y, 3 times negative 3 plus 1 is less than or equal to 7. Negative 9 plus 1 is less than or equal to 7. Negative 8 is less than or equal to 7. Yes? Plugging in the next it into the bottom one. 4 times negative 3 minus 2 times 1 is less than or equal to 8. So negative 12 minus 2 is less than or equal to 8. Negative 14 is less than or equal to 8. Yes, so this one would be. Not bad. Okay, we're down to our last few examples. Now these are the big ones. Here are the big ones. This is when you're going to have more than just 2 restrictions. You're going to have many, but it works the same way. It's just a lot to think about. So, but you got it. We got this. Okay, so here we go. Writing it in mx plus b form. I only have 2 more examples, maybe 3 if you want 3. We'll see, but 2 more for sure. So we would get it in mx plus b form, subtract x, y value is less than or equal to negative x plus 5. Is everybody good with that? Get y alone, subtract 2x, y value is less than or equal to negative 2x plus 7. Then we only can have our x values greater than or equal to 0, and our y values must also be greater than or equal to 0. So let's graph this top one. Y-intercept of 5, and then a slope of negative 1. It's including, so it's solid. And then I would definitely write on this one above or below. Y value is below the line, so we're shading below. Next one. Y-intercept of 7 down 2 over 1. Down 2 over 1. Okay, is it solid? Okay. Now that one's also below, right? Y value's below that line. Okay, now I'm going to do these next two in green. So this is what our next statement is. All x values have to be larger than 0. So here we go. Here's x equals 0, right? It has to be greater than, or it says it can be equal to 0. So won't that be all of these values? Right? Look, these are the negative x values. They can't be solutions. And it has to be greater than, so that's why I pointed an arrow this way. It's going to be this way, larger than that. Then also, y values have to be larger than 0. Here's my y-axis. Aren't these the negative y's? So they cannot be in the solution because it said it has to be greater than or equal to 0. So we also have a solid line going up like this. It has to be above and over. So it's in quadrant 1, this one. Do you guys see? Okay, let's shade it now according to what we see. Has to meet all the criteria. So let's think very carefully. It has to be in the green section. And it has to be below both. Right here is above red, isn't it? So that wouldn't work. Right here is above blue, right? So that wouldn't work. We need to be above both. What about over here? Is this above red? Right here? Yes, is it above blue? But then I gotta just stay in the green too, right? I can't come outside of that. Does everybody see? Oh, it's below. No wonder I'm confused. Okay, pause, rethink. I'm confusing everybody. It's below. Why am I saying above? Am I saying above? Yeah. Or am I just saying below and pointing above? Okay. Below. Okay, so we gotta be below blue, but right now I'm above red. I gotta be below red and below blue. Isn't that right there? Does everybody see? Okay, so it's actually this little section right there, because that's below the blue and below the red, and it stays in the green lines. So the solutions here are only the points that fall in that teeny little space. So, I mean, I could, just so you guys know, like, once again, this is a solution because they're all dotted. I mean, they're all solid lines. This is a solution, and everything in between here. Does everybody see? Okay, so it asks us, is it bounded or unbounded? So guys, here's what makes this a bounded problem. If your solution is bound to like a space that like is cut off, like one specific shape, that's bounded. If it goes on forever, it's not bounded. Isn't this one only this specific set of points? I can draw a circle around it. That would make it bounded. So this one is bounded, yes. And then if I ask you what are the corner points, you would say, it means it wants to know, since it's bounded, what are the corners that are blocking this off? So our corners would be 0, 0. The next corner would be over 0 up 5. The next corner to me looks like over 4 up 0. And then we could even kind of call this one somewhat of a corner point. Do you agree? Because it's kind of like ding ding, kind of a corner. So we could call that a corner. That's over 2 up 3. Okay, so was this one bound? No, because see how it goes on forever this way? Okay, good. You guys get the picture. Okay, let's do another one like that. We're doing good though. So y equals mx plus b. Subtract 2x. This will be my last one if you want it to be. Subtract x. Oh, I like this one. And then divide by 2 because it's not pretty, and I want you to not freak out if you see something like this. I'll talk about what you should do. So up here we have y values larger than or equal to negative 2x plus 13. Is that correct? For that one? Then we have right here y value is greater than or equal to, I subtracted x, then I divided by 2 to get rid of that stuff. So I'm going to say negative 1/2 x. And then we have plus 11 halves. Now that's not pretty. I'm not going to want to graph this like that with using that 11 halves, but we'll talk about how the smart way to do that one. Then also x's have to be greater than or equal to 4, and y's have to be greater than or equal to 0. This will be my last example. Okay, here we go. Let's plot points. Now everybody look. Can I go up to 13? No. So I'm not going to start, that's x equals 0. So watch. If I made an xy chart to see what the next point is, let's plug in 0, we get 13. Does everyone agree? Plug in 1, negative 2 plus 13 is 11. I still can't graph it. Okay, let's move on to 2. Negative 2 times 2 is negative 4. Negative 4 plus 13. So 9. I actually can pretty much plot that. So I'm going over 2 up 9 units. Does everybody see? And now guess what I can do? I can just continue with the slope. Slope is going to be the same from every point, right? So now I'm going to go down 1, 2 over 1, down 1, 2 over 1, down 1, 2 over 1. Okay, and then it's including, so solid line, and it's above or below, you tell me. Okay, above. Next one. Okay, everybody gets freaked out by these fractions because they're like, and then their graph is really hard to graph. If you have a fraction, do an XY chart and only plot like a whole number point and then go from there. So let's plug in 0. We get 11 halves. We're not going to plot that. We could, but it's going to be harder. Let's just do it this way. Plug in a 1, everybody. So that's negative 1/2 plus 11 halves. We can add them because they have common denominators, so that would be 10 divided by 2, which is 5. Let's start at that point, how about? Over 1 up 5 units. And now we can just continue with the slope. So down 1 over 2, down 1 over 2. And then solid line. Is it above or below? I'm going to write it right here. Okay, I'm going to do it, these next two in green. Now the next restriction is the xi's have to be greater than 4. Here's the xi of 4. I'm going to cut it off here, and it needs to be that way. Only values that way of 4, right? Greater than 4. And at the same time, it has to be y values above 0. So here's y values above 0. So only here up can be solution. So I'm cutting it off also right here, aren't I? It has to be above that. Oh, I don't know why I drew up, but just pointing up. I just shouldn't have cut it off here, right, necessarily. You get why is that confusing? Okay. Okay, so it has to be on this side of green, above green, and then it has to meet this criteria. Here we go, we got this. Okay, above red and above purple. Wouldn't that be right here? But then we have, but right here, more so. Because I was below red for a second. But then it has to be within that green section. So to me, it's looking like all that stuff. Do you agree? Sweet. Is that one bound? No, because it goes on forever. So not bound. So there's not corner points. That's the last example. It really just takes digging in, practicing these yourself. It really does. So I won't do any more. So go ahead and do 4.6. I would practice some on that. Because if you can do 4.6, you can definitely do the other one. I do have a key. So you can check your answers while you're in here today, and then I'll upload it to my website as well.